Holiday Written, Chapter 5, Problem 34. A crate of mass 100 kilograms is pushed at constant speed up a frictionless ramp, theta equals 30 degrees, by a horizontal force, F. What are the magnitudes of A, F, and B, the force on the crate from the ramp? So the gravitational force that wants to pull this box down the ramp is mg sine theta. And you look at the force that's pulling the box up the ramp, the dot product only picks out the direction that the box is moving. So this would be F cosine of theta. And theta is 30 degrees, because we're not worried about this here, but this would be F sine of theta. So when we sum our forces in the x direction, we're going to make this x in the positive and y. So we have sum of f x's is going to equal f cosine theta minus mg sine theta is equal to ma. Now the problem says that it's pushed at a constant speed up a frictionless ramp. So that means that A is equal 0 since it's pushed at a constant speed. There's no forces on it for us making it accelerate. So F cosine theta is equal to mg sine theta. And when we solve that, we have F is equal to mg times the tangent of 30 degrees, and that's equal 100 times 9.8 times the tangent of 30 degrees is equal to 565.8 newtons, which is equal to 566 newtons. So now we want the forces on the box due to the ramp. We want the normal force. So we'll say Fn. We're going to sum our forces. We look over here. We have F sine theta. That's from that force that's pulling it up the ramp. And it's in the minus direction. Minus F sine theta. I don't want to confuse this Fn with this F here, so I'm just going to put F normal, that they're different. Then we have mg cosine theta. Fn minus mg cosine theta is equal to ma. And we know that the box do not leave the ramp, so we say the acceleration is 0. Now we can just solve for Fn. This pen works better. Fn is equal F sine theta minus mg cosine theta. Now we figured F to be 566 newtons, so we can say 566 times the sine of 30 degrees minus the mass of the box. No, that's not a minus sign, it should be plus. You took both of these minuses over, they're plus. 100 kilograms times 9.8 times the cosine of 30 degrees. And this will equal, so Fn is going to be 283 plus 848, which is equal to 1.13 times 10 to the third newtons. Now, I want to untangle something to make sure you understood. This is the force of the box being pulled up the ramp. And this is F cosine theta of this force, and this is F sine theta of this force. The normal force have an equal and opposite force. That's why it doesn't fall through the ramp. And here's gravity, mg here. And so this, of this triangle, that's a right angle, that's 30 degrees right there, is mg cosine theta. And we just added all our forces in the y direction. That's what this was about. Fn, mg cosine theta, and Fn sine theta. And that gave us 1.13 times 10 to the third newtons.